Good afternoon, ladies and gentlemen. Welcome to Math 20-1, review of Chapters 3 and 4, Quadratic Equations and Functions. Now, this is the review just before the final exam, or your retest. So, basic stuff you should remember. First things first, factoring x squared plus 9x plus 20. What are two numbers that add together to be 9 and multiply together to be 20? Well, anything can add together to be 9, lots of numbers, but it's to multiply by 20. If you think about it for a minute, x plus 5 times x plus 4 works out, answers your question. And remember, if you're having trouble with this, do the foiling. X times x is x squared. X times 4 is 4x. 5 times x is 5x. 5 times 4 is 20. So we get x squared plus 9x plus 20. When in doubt, multiply it out. Now, that's a large part of this chapter is factoring. Now, I was going to say a few standard tricks. 5x squared minus 10x minus 75. You are going, oh my god, there's a number in front of the x squared. But you can divide everything here by 5. So this becomes 5 times x squared minus 2x minus, 15. So, what are two numbers that add together to be minus 2, could be anything, but multiply together to be minus 15? Well, that's x minus 5 times x plus 3. And don't forget the 5 in front. Okay? So that's a large chunk of this chapter, factoring. Now, that leads to the next part, solving. Now, x squared plus 9x plus 20, we just said x plus 5 times x plus 4. But here we're solving. That is setting it equal to 0. So x plus 5 is equal to 0. Subtract 5 from both sides to get x all by itself. X equals minus 5. Or x plus 4 equals 0. Subtract 4 from both sides. X equals minus 4. All right? So that's solving. That's the other half of chapter 3. Now here, notice I'm asking yourself 2x squared minus 9x minus 5. You can't factor anything out. So you're down to 2x squared minus 9x minus 5. So I like using these rectangles. What are the factors of 2x squared? Well, you have to have an x and a 2x. Now, what are the factors of minus 5? Well, minus 5 is minus 1 times 5, or 1 times minus 5. So that gives you lots of options. So let's do a little bit of math here. If you're ending up with a middle term of minus 9x, means, well, you're multiplying by 5. Well, it has to be 2 times minus 5, I think. So 2 times minus 5 is minus 10x. X times 1 is 1x. They add together to be minus 9. So yes. So this is x minus 5 times 2x plus 1 equals 0. Now in that instance, and I'm running out of space, so I'll cram it in on the side. X minus 5 equals 0. Add 5 to both sides. X equals 5. Or 2x plus 1 equals 0. Subtract 1 from both sides. 2x equals minus 1. How do I get rid of times 2? Divide both sides by 2. X is minus 1/2. Those are my two solutions. Okay? Now, I was going to say, oh, I forgot to throw at you my standard trick question. Difference of squares. What if you got x squared minus 9? Well, remember, that's x squared minus 3 squared. So that's x plus 3 times x minus 3. And I'll leave you to figure out what the two solutions are. Because I want to go on to the nasty one. 2x squared minus 9x minus 6 is 0. Now this one is nasty because you can't factor it. You cannot factor out a number from each term. And if you try foiling it or doing the box, it doesn't work. You have to use the quadratic equation. Yes, the quadratic equation. X equals minus b plus or minus the square root of b squared minus 4ac over 2a. In this instance, coefficient b is minus 9, so this is minus 9 plus or minus the square root of minus 9 squared minus 4 times a, which is 2, c, which is minus 6, 2 times 2. So plugging the numbers in, this is 9 plus or minus square root of 81. 4 times 2 is minus 8. 6 eighths are 48. So that's plus 48. Yes, it's divided by 4. Now 81, 89, 129 over 4, I believe. Okay? So, just double checking. Okay, now what can we say about 129? Can we factor it? We can't divide by 2. Can we divide by 3? Yes. That is 2 times 43. Uh-oh, it's 43 prime. Oh dear, we can't divide it by 3, we can't divide it by 4, we can't divide by 5, we can't divide by 6, we can't divide, oh shoot, that is prime. 3 times 43, so we can't factor it. Poopy, poopy, poopy. It's a poor example. I'll have to go back and fix that. But what happens if you had, no, sorry, two things here. One, I want you to know that is an exact value, not a decimal approximation. If you tried on a test to give me, graph it and give me the decimal approximation, I'd be annoyed with you if I asked for exact value. The other thing is, what happens if you got an answer 6 plus or minus square root of, say, 72 over 2? All right? Well, 72 is 2 times 36, which is 6 times 6, 2, 3, 2, 3. So this is 2 times 2 times 2 times 3 times 3. And notice it's a square root. So I'd be looking for pairs. 2 squared and a 3 squared and a 2. 2 times 2, square root of 2 squared is 2, square root of 3 squared is 3, and we got a square root of 2 left over. So this we would rewrite as 6 plus or minus 6 square root 2 divided by 2. And then we could factor stuff out. That would be 3 plus or minus 3 square root 2. Then I'll go back and fix that. Anyway, you have to be able to use the quadratic equation, and you have to check to make certain you can simplify them. Okay? Make that a little neater. All right. Now, a minor thing, completing the square. So that becomes handy later on. So remember this, how to do this. Well, this is y equals x squared minus 8x minus 6. Now, I would suggest you rewrite this as the minus 6 over here, because you have a b value of minus 8. 1/2 your b value is minus 4, and 1/2 your b value squared is 16. So, now, here I have to be careful because there's a couple different ways to do this. And I'm having a complete brain fart which way I showed you. Did I add 16 to both sides? I think I did. I'll do it this way. So y plus 16 equals x minus 4 squared minus 6. Now, here I've got to get rid of my 16. Now, different versions of this, I would just go minus 16 on this side also, but no, I don't think I showed you that way. Anyway, I hate this getting old. I used to be able to remember this. X minus 4 squared minus 22. That's completing the square. Now, the nice thing about this is it gives us our vertex, P and Q. It tells us where the vertex is, and it makes it very easy to graph. Now, if I asked you to solve this, you're going, that doesn't look like a quadratic. And it's not. But if you multiply both sides by the common denominator, x squared, what have you got? 3x squared plus x equals 1. Or 3x squared plus x minus 1 equals 0. Subtract 1 from both sides. And then you have a quadratic equation. Now, I encourage you to try factoring that. I don't think you can. Grab the quadratic equation, plug it in. I'm not going to bother. This is a review, and I've shown you the quadratic equation already. Now, remember I was talking about the vertex there? Well, this is standard form of a parabola. Now it's easy to describe and graph. The vertex right here is 4, 8. The axis of symmetry, x equals 4. So A, P, Q. I will be using those terms. The y-intercept, I don't know, but here x is 0, so plug in 0 and solve. 0 squared, 0 minus 4 squared is minus 4. Minus 4 squared is 16. 16 times minus 2 is minus 32. Minus 32 plus 8 is minus 24. Now that's a pain. Domain, that's easy. X is all real. The range, that's easy also. The minus 2 means it goes down. So it's y is less than or equal to 8. My maximum y value is 8. Now the x-intercepts, that's another pain to do. I can do that graphically. I can multiply it out. If I want exact values, I would have to multiply this out and plug it into the quadratic equation. And I'm not doing that. Way too much work. Or I could solve. 0 equals minus 2, x minus 4 squared plus 8, and solve for x. That sucks. I could do it. Suppose subtract 8 from both sides. Minus 8 equals minus 2 times x minus 4 squared. Divide both sides by minus 2. 4 equals x minus 4 squared. Square both sides. X minus 4 equals plus or minus 2. So x equals 4 plus or minus 2. Add 4 to both sides. So x plus 2 is 6 or 2. So that is doable. But it's just, and in this instance, I happen to get a nice number. But it is a pain. So for this version, the x-intercepts and the y-intercepts suck. But domain and range, axis, symmetry, vertex, and drawing the graph is quite easy. Now, I didn't draw the graph because I'm being lazy. I should do that. So my vertex is 4. 1, 2, 3, 4. And Q value 1, 2, 3, 4, 5, 6, 7, 8. So something like that. Now my A value is minus 2. Normally my graph goes over 1, up 1, over 2, up 4, over 3, up 9. I told you to memorize that table. Now you're multiplying your y value by minus 2. So it goes over 1, down 2. Over 2, instead of down 4, it goes down 8. So that's the advantage of the standard form. It's easy to graph, and it's easy to describe, but the x and y intercepts are difficult. Now, the general form, this is easier to factor and solve. So this is x plus 3 times x plus 1. So my domain, it's a parabola. X is all real. My range, I really don't know. I have to graph that. That's a pain. The vertex is another pain. I'd have to graph it. I'm not going to because I'm lazy. But the x-intercepts, that's easy. X plus 3 times x plus 1 equals 0. X is minus 3, minus 1, minus 1, minus 3, minus 3. X equals minus 1. That's just solving. And if this was a nice one, I could have easily given you one where you had to use the quadratic equation. Now, converting backwards and forwards. As I said here, if you want to convert from standard form to general form, you multiply out. That's fairly easy. I'm not going to bother doing that. But going backwards, converting it to general form can be try this again. Hi guys. Going from general form to standard form is something I want you to be able to do. That is, so you can graph it and find the vertex. So how would you do that? Well, y equals 3x squared plus 24x plus 17. Now, How would I convert this? Well, it's just like, well, it's a lot like completing the square. First things first, notice it's 3x squared. So you got to get rid of that by dividing everything by 3. So 1/3 y equals x squared plus 8x plus 17/3, whatever that is. Now here, I have a b value of 8. 1/2 my b value is 4. And 1/2 of 4 squared is 16. So I add 16 to both sides. Okay? So this is 1/3 y plus 16 equals x plus 4 squared plus 17/3. Now I've got the x plus 4 squared part, which is important. I want to get rid of I want to make it y equals. So subtract 16 from both sides. So 1/3 y equals x plus 4 squared. Now, I'm going to have to cheat and grab Mr. Calculator because I'm not doing this in my head. 17 divided by 3, or you shuzzbot. 17 divided by 3 equals minus divided by. That's minus, my apologies, 10.333. That's what Mr. Calculator says. Now, I encourage you to put that into a fraction, math fraction, minus 31 over 3. Now, I'd rather you leave it as a fraction, because what's my next step? Well, I've got 1/3 y. How do I get rid of 1/3? Multiply everything by 3. So this becomes y equals 3x plus 4 squared minus 31. Woohoo! Almost like I know what I'm doing. Now, where's my vertex? Well, it's x minus minus 4. So my vertex is at minus 4 minus 31. And my a value is 3, so it's going over 1, up 3, over 2, 3 times 4, 12. So that's easy to graph. Let me write that a little nicer. Minus 4 minus 31. There we go. That's what I expect you to be able to do. Now, other couple bits. What's the equation of the parabola that has a vertex at 5, 7 goes through minus 3 minus 1? Well, PQ. So this is y equals a x minus p squared plus q. Y equals a times x minus minus 5 squared plus 7. Now, I also gave you 2 points, an x and a y. So every time you see y, you replace it with minus 1. Every time you see x, you replace it with minus 3. And then you solve for a, the only thing you don't know. Okay. Now, I'd subtract 7 from both sides, so minus 8 equals a times minus 3 plus 5 is 2 squared. Minus 8 is 4a, divided by sides by 4. A equals minus 2. So the equation for this parabola, sorry, I'll just show you that again. I did that kind of fast. A is minus 2. So this is y equals minus 2 times x plus 5 squared plus 7. Now, I'm not going to prove it, but you guys graph this and see if you get a vertex here and these coordinates on your table of values. You should. I'm just too lazy to do it. Now, last thing, and yes, last thing. What's the equation of this parabola? Well, it's the exact same thing as what we just did. Here's P, here's Q, my X and my Y value. So I'll do this quickly, just to prove it can be done. So Y equals, actually no, let me change colors. Green. Y equals A, X minus P squared plus Q. So every time I see P, I replace it with minus 2, and every time I see Q, I replace it with minus 3. So y equals a x minus minus 2 squared minus 3, or y equals a x plus 2 squared minus 3. Now, every time I have an x value, I replace it with 0, and a y value I replace it with minus 1, and I solve. So how do I get rid of a minus 3 over here? Well, I'd add 3 to both sides. So 2 equals a times 2 squared. 2 equals a squared 4a. Divide both sides by 4. A is a half. So this equation is y equals 1/2 x plus 2 squared minus 3. Okay? Now, if you don't believe me, graph it. Actually, graph the damn thing. As I've harping on before, if I give you an equation and a graph it. And you should have these two data points, -2, -3, and 0, comma, -1. All right? Now, that's basically it for chapters 3 and 4. No, I haven't hit everything, but I've hit the high points, everything you should be able to use, or everything you need. All right? Any questions, shoot me an email. Otherwise, good luck.